The method I'm going to use to graph these sinusoidal graphs that have had transformations and translations, so numbers being added in, is a little different than the method in the content. You pick which method makes most sense to you. If you like how they did it, where they graphed the basic one and then applied each number one at a time to get the final graph, that's great. I pick apart the information and set up my graph and kind of do it all at once. I find it works better with sine and cos graphs because the numbers A, K, B, and D have meaning. They actually translate to something physical on the graph that we can talk about. So when I'm looking at this, A is the number in front of the cos or the sine, K is the number in front of X or the bracket, B is the number being added or subtracted inside the bracket, and D is at the number at the end. I always start by looking at D because D is the up or down movement, or in this case, it is just where the axis of curve or the middle of my wave is going to be. Because there's no D in this case, it's really 0, so that means my axis of curve is at y equal to 0. So if I'm setting up my graph, I already know that this is going to be the middle part of my graph. This will be where I wind around. The next thing I look at is the A. So I go from the very number at the end to the front. And in this case, A equals 3, and A stands for amplitude. So that means from my axis of curve, I'm going to be going up 3 and down 3 because those are the size of my waves. So if I come to my graph, I like to mark my ceiling or my top point, which is 3 above the axis of curve, and my down point, which is -3. Now I look at B, and B is the phase shift. It is still a horizontal shift. They just like it to sound fancy when we're talking about waves. And in this case, because it's minus 90 degrees, just like before, it's opposite. So that means my graph is starting right 90 degrees. Sine and cos usually start on the y-axis, but this case, it's going to start at 90 degrees. So I'm going to give myself a dotted line as a reference point. Now, it depends on if we're doing sine or cos, and I have the basic shape memorized. Sine always starts in the middle, so where my starting point intersects my axis of curve. Cos always starts up. So right away I know that's the first point on my graph because it's moved forward 90 degrees and cos starts at the highest point. So now the only other thing I need to worry about is K. And K is how many shapes you'll see in 360. In this case, we don't really have a K value. It's a 1. It can't be 0 because if it was 0, this whole bracket would go away. But it's K equal to 1. So that means one shape in 360. So 360 degrees is our period. That's just normal. That's a regular graph. Now, how I figure out how to move things or how to jump is a normal sine or a normal cos graph always has 4 points. So if I start there, or 4 movements, 1, 2, 3, 4. Similarly there, I start here, 1, 2, 3, 4. So to get the size or how many degrees are in each kind of section, you always take your period and divide it by 4. So that gives me 90 degrees in this case. So every 90 degrees, I'm going to have a change. Well, I made my scale 90 degrees, so that means every point I'm going to do the movement, and I can keep this going as much as I need to, forward and backwards. And then I join them up best I can with a smooth curve. Oops. And this is the graph of y equal 3 cos of x minus 90 degrees. So you can see instead of building it up piece by piece, I interpret each of the numbers and build my graph from there. So here's one that has a lot going on. A, K, B, and D. But instead of getting overwhelmed, I start with my D. So D equals -2, so that's where my axis of curve is. So I go to my graph, and there's my -2. I literally go to where -2 is. There's my axis of curve. Next thing I'm going to look at is my amplitude. In this case, amplitude is 1/2. So that means from my axis of curve, I'm going to go up 1/2 and down 1/2. So I kind of mark my floor and my ceiling. So -1.5 is my highest point, and -2.5 is going to be my lowest point. So this is going to be a fairly squished curve. Now I'm going to go to my phase shift. So B equals positive 180 in this case. So that means it's going to go left 180 degrees. Now I'm going to be careful because what's happening is I have a K here. So I'm going to wait to mark that on until I come up with an appropriate scale for my x-axis. Because if I just go by 90 now, it may or may not work out for me. So in this case, K equals 3. So that means I'm going to have 3 shapes in 360 degrees. So my new period, whoops, I'm thinking ahead to the answer. 360 divided by 3 is 120 degrees. So instead of completing one shape in 360, I'm going to complete one shape every 120 degrees to get 3 in 360. That doesn't mean much to me though. I need to know how I need to move along making my points. There's always 4 movements. This number never changes. So if I divide that by 4, I'm going to have 30 degrees. That gives me a big hint as to how to set up my graph. So I'm literally going to count by 30s. 30, 60, 90, 120, 150, 180, and I'm going to do the same thing going backwards. So now, by making each square 30, I'm still going to bounce or move every square, and left 180 degrees is going to be, I went the wrong way, right here. There's my starting point. Now the graph I'm working with in this case is sine. Sine always starts in the middle, and I have to bounce every 30 degrees, which I made my life easy. I made every square 30 degrees. So I'm going to go up, down, down, up, up, and I'm just going to keep this going all the way along. Whoops, ignore that. That should be there. And I'm going to join them up as best I can. So there's the graph of y equal to 1/2 sine of 3k plus 180 minus 2. So again, I don't build it one step at a time. I interpret all of the information and go from there. So now we have -3 cos of 1/2 x minus 90 degrees. There's a problem with this one. The k cannot touch the x if there's a b as well. So I have to bring that 1/2 out in front of the bracket. It's not a problem to take 1/2 out of 1/2 x. I just move it out. But to take it out of the 90, I'm factoring or dividing. So I do 90 divided by 1/2, or 90 divided by 0.5, which gives me 180. It's not 45 degrees. 90 divided by 2 would be 45, and that's not what I'm doing. But that's a common mistake students make. If you don't believe me, type it into your calculator. 90 divided by 0.5, and it should tell you 180. So picking the information out, d is 0. So my axis of curve is still at y equal to 0. My amplitude is 3 in this case. So my ceiling is going to be 3 and my floor is going to be -3. 3 above and 3 below this axis of curve. Now there's a negative involved there. So this is going to flip my graph upside down. I don't have to worry about that yet, and I'll show you how I take that into consideration. But the 3 is my amplitude. Amplitude is a measurement. It can never really be negative. The negative is separate or means something different in this case. It means a flip. My B is 180 degrees to the right because it's subtract 180. I'm going to be careful with my unit in this case because my k is 1/2. So that means I'm going to get 1/2 of a shape in 360 degrees. So to get my new period, I do 360 divided by 1/2 or 360 divided by 0.5, and you should get 720 degrees. So if I only get 1/2 of a shape in 360, it makes sense that I'd have to have a full 720 degrees to see a full shape. To think about what's going to happen, I'm going to divide that into 4 to figure out how I should space this out. And 720 divided by 4 is 180 degrees. So on my graph, I'm actually going to count by 180 degrees. I'm going to go 180, 360, 540, 720. And it'll be the same in this direction. And that's just +3 and that's -3. So now when my starting point is 180 degrees right, that's just one space according to my scale that I set up. If you're smart with your scale, it becomes easier to graph these things. Now, this was cos, but remember, because our amplitude had a negative in front of it, it's been flipped. Cos usually starts up at the top, highest point, but because it's been flipped, I'm going to start down at the lowest point. Cos usually starts here and winds. I'm going to start there and wind. Because I was smart with my scale, and something happens every 180 degrees, I just made every space 180 degrees. And so now I just bounce or move or change every space. And there's my graph. This is y equal to -3 cos of 1/2 x minus 90 degrees. I labeled it with the original equation. It wouldn't be wrong if you labeled it with the equation that we took the 1/2 out of. So now the last one says, for the graph shown, find a sine equation and a cosine equation, because sine and cosine have the same shape, so you can do either or. So whenever I'm doing this, I look at the graph and I'm going to do, whoops, that shouldn't be there. I had erased it originally. I'm going to look for my axis of curve. Now the axis of curve is in the middle. So if you can't visually see where that middle point is, it's the average of the highest and the lowest point. So to average two numbers, I add them up and divide by 2. So now my axis of curve is at 4. Once I have my axis of curve, I can figure out my amplitude. So d is going to be 4 and my amplitude is going to be 5. Now k is how many in 360 degrees. So you can count how many. I get 1, 2. So in this case, k is 2 because I get 2 full revolutions in 360 degrees. Another way to do it is to say, okay, I get 1 in 180, so that's my new period. The old period is always 360 because that's the normal. And the old period divided by the new period will always give you k. So in this case, it would be 360 divided by 180 if you can't see what k is. Because the cool thing is, for sine and cosine, the axis of the curve is the same, the amplitude is the same, and the k is the same. The only thing different is the starting. Sine starts at 0. So a sine equation could be y equal to a, which is my amplitude, which is 5, sine of k, which is 2, x plus beta. Well, in this case, I haven't moved. I'm starting still at 0, so I don't need it. And then my axis of curve, plus 4. But you could say, well, wait a minute. Sine also starts right there. So another correct equation could be that, where you move ahead 180. There's really an endless number of right answers because you could also flip it. I could say I have an upside down sine, starting at 90 degrees. I like the simplest one, so I like this one, but any of them would be right. So now for cos, all I really have to do is find a starting point. There's a starting point for cos right there, and it's forward 45 degrees. So that means I'm going to have subtract 45 degrees in my equation, but everything else is the same. So y equals 5 cos of 2x minus 45 degrees plus 4. You could also have minus 225. You could have plus 135, any of those points. But whoops, once you have the axis of curve, the amplitude, and the k, they never change. Sine and cos just start at different points. So it's different starting points that change what it is.